Okay, you guys, welcome to the last lesson of Chapter 5. We're talking about inequalities in triangles. Our first corollary here is that we have the three angles in a triangle. We have the measure of angle 1 is greater than the measure of angle 2. Well, of course, the measure of angle 1 is greater than the measure of angle 2. And the measure of angle 1 is greater than the measure of angle 3. Well, yeah, it's bigger than that too. So what we're saying is if A equals B plus C and C is greater than 0, then A is greater than B. Another theorem that goes along with this is that if two sides of a triangle aren't congruent, then the larger angle lies opposite the largest side. So the largest angle is opposite the longest side. And the converse of that one is if you have angles that aren't congruent, then the longest side is across from the largest angle. The last thing that we have here is that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. In order to show you this, it's going to be this side plus this side is going to be more than this side. Again, this side plus this side is greater than that side. Finally, this side plus this side is greater than that side. That's all we're saying. So now we move on to the examples. If we're going to apply that corollary, we're looking to use the figure at the right to compare these angles. So I'm going to look at angle 1 right here and angle 6 right here. And I'm going to say angle 1 is greater than angle 6. And look at the next one. We've got angle 2 and angle 1. Oh gosh, it looks like angle 2 is less than angle 1. Whoops. Less than angle 1. All right. Number 3, look at the angle number 6. Angle number 6 and angle number 3. Well, 6 is exterior, so this one is going to be less than angle 3. I mean, greater than angle 3, sorry. And then angle 4 and angle 6. Again, angle 6 is exterior, so that means that angle 4 is less than angle 6. Okay, so now to apply this to a real triangle here, we're looking at the triangle RGY, and RG is equal to 14. RG, oops, I want to use red. RG is 14. Okay. GY is 12. And RY is 20. Now it says list the angles from largest to smallest. Well, if I look at the sides, I notice that RY is the longest side. So I'm going to take the angle opposite it. That's going to be the largest angle. So angle G is the largest. The next one is 14. Take the angle opposite 14. That's going to be angle y. And then 12 is the smallest number, so we're going to take the angle opposite. That's going to be angle r. So that's listing them in order from largest to smallest. So now I have to list the angles of this triangle in order from least to greatest. If KL is x minus 4, LM is x plus 4, KM is 2x minus 1, and the perimeter, this is a big word. They're not saying that for fun. They're saying that because it'll give us something that we already know. The perimeter of KLM, the triangle, is 27. So if the perimeter, the distance all the way around this triangle, is 27, that means I'm going to have to take KL, LM, and KM and add them all up. And I'm going to set it equal to 27 because that's the distance around. So KL, LM, okay, sorry guys. KL is here, LM is here, and KM is right here. So we're going to add all those up to equal the perimeter. So that will be x minus 4 plus x plus 4 plus 2x minus 1 equals 27. Okay, so now, wow, that's a lot of x's and numbers, isn't it? Let's combine like terms. So that's going to be 2x plus 2x is 4x. And now we have the numbers. Let's negative 4 plus 4 is 0, minus 1. So it's minus a negative 1, 27. Okay, so I'm going to add 1. Add 1. I get 4x equals 28. So x equals 7. Am I done? The answer is no, because now I have to plug it back in. I'm going to plug it in over here. X becomes 7, so 7 plus 4 is 11. X minus 4, so 7 minus 4 is going to be 3. 2x, 2 times 7 is 14 minus 1, that's going to be 13. Now, we can figure out the angles, the order of the angles. 13 is the largest one, so I'm going to say angle L is the largest because it's the largest side, opposite the largest side. Angle L. Then 11 is the largest side, so I'm going to go to this angle over here, which will be angle K. And then angle M is across from the shortest side, which is this 3. Okay, now we have to find x and list the sides in order. So if I'm looking at the picture, I'm seeing that the x's are in the angles this time. You remember last time, the last one we did, we talked about the perimeter. Now we've got the angles. Well, that's easy enough because we know that all 3 angles in the triangle add up to 180. So we're going to take measure of angle A plus the measure of angle B plus the measure of angle C and set it equal to 180. Okay, so 9x minus 4 plus 4x minus 16, that's supposed to be green, plus 68 minus 2x equals 180. So again, we're going to combine like terms. I've got 9x plus 4x is 13x, minus 2x is 11x. Then I've got negative 4 minus 16, which is a negative 20, plus 68, which is 48. So we're going to say plus 48 equals 180. So now we end up with 11x equals 132. And x equals 12. Well, we're not done yet. So in order to get these measurements, we need to plug the x back into the measurements of the angles. So in this case, we got 4 times 12 up here, which is 3. Angle B is 4x minus 16. Where did I get that? Never mind. 4x minus 16. So we're going to plug in the x here, which is 12. So we get 48 minus 16, which then is 32. For angle C, we've got 68 minus 24, which turns out to be 44. And then we've got angle A, which is 9 times 12 minus 4, which works out to be 104. Okay, so now I can tell you the biggest side, the longest side, is going to be opposite the 104. So opposite angle A is this side over here, which is the longest side. Well, we can see that, but now let's put that theory into action. So that side is going to be, CB is the longest. The next one will be the opposite R44 over here. So that's going to be BA. And then we've got this one, opposite CA. And you're probably wondering why you just didn't eyeball it and figure that out. But sometimes all these triangles will not be drawn to scale. You won't be able to tell which one is the longest. It'll just be a triangle and you have to figure it out. Okay, now here's a question for you. Using inequality theorem, can a triangle have sides with the given lengths? Okay, so here's what you do. You've got this triangle 4, 4, 6, and 9. Well, what I'm going to do is I'm going to say, if I add, like I showed you on the first page, I add these two, they have to be bigger than this one. So if I add 4 plus 6, is it greater than 9? The answer is yes, 10 is greater than 9. So I'm going to do the other two sides as well. So I'm going to use 6 plus 9. 6 plus 9 is greater than 4. Well, is that true? Of course it is. 15 is greater than 4. Final one is 9 plus 4. 9 plus 4 is greater than 6? Yep. 13 is greater than 6. So in this case, yes, a triangle can have those 3 sides. By the way, you guys, it's December now, so I was thinking maybe we could do a little riddle here. What did one snowman say to the other snowman? You give up? Do you smell carrots? So I want you to write carrots next to number 6. As we move on, we're looking at the algebra of the triangles as well. So what we have is a triangle. We have 2 sides that are given. We've got 5 inches and 16 inches. X is our third side. So now we have to figure out what lengths could possibly have be the third side. So what we do is we set up three equations, just like we did in the last one, except we're using x as the third side. So now I solve this. I say, okay, 5 plus 16 is 21. 21 is going to be bigger than that third side. I solve the next one. 5 plus x is greater than 16. So now I have to do some math to get x alone. So I'm going to take 5 away from both sides. And I get x is greater than 11. Okay, that law looks good. Now for the third side, for the third equation, we're going to do this next one. I have to get x alone, so I'm going to take 16 away from both sides. And I've got x is greater than negative 11. Well, we can't have a negative length, so this one we're not going to use. So if we look at the blanks up here, we say that x is greater than, well, if you look at the statements here, x is greater than 11, and x is less than 21. So the side has to be between 11 and 21 units long. You're going to be asked to do some problems like this, where we're looking at a triangle and figuring out the small, medium, and large sides. So if we look at angle A, that is the smallest angle. So what's the smallest side of this triangle? It's across from the smallest angle. So BD is the smallest in triangle ABD. Okay, so now we look for the medium. The medium angle would be 59, and it's across from this side, which is AB. And then our third angle, the largest angle, across from the longest side, AD. So now we're looking at the other triangle. We're going to start with the smallest angle. Well, the smallest angle on this triangle is 55. So we're going to go across to the other side, which is BC. The medium-sized one is going to be 60 across from BD. And then our largest is going to be DC. Now the overall shortest side is going to be the one across from the smallest angle. Well, the one with the smallest angle is A, so the shortest side is going to be BD. Okay, that's it for today. Have a good night.